In this video, we're doing another problem with the domain of a multivariable function, and we've been asked to identify and sketch the domain of the function and then to evaluate it at the point 3, 2. The function we've been given is f of xy equals x natural log of y squared minus x. So we've got a multivariable function. We could just as easily write this z equals x times the natural log of y squared minus x. They're the same thing. So we've got a function for z in terms of x and y, and we need to find the domain. Well, whenever we're trying to find the domain of a function, we're looking for the points where the function is undefined. And in this case, the only points where this function could be undefined is where the value inside the natural log is less than 0, because the natural log function, the real part of it at least, is only defined when the value inside the natural log is greater than or equal to 0. So if this value here, y squared minus x, is less than 0, then the natural log is going to be undefined, which is going to make the whole function undefined. So what we want to say then is that the domain of this function is going to be everywhere where y squared minus x is greater than 0. Because if this value is less than or equal to 0, then the function will be undefined. So this is the domain of the function. We could also write it as y squared greater than x if we add x to both sides of the inequality. And if we just flip this inequality around, we could also write it as x less than y squared. So whenever x is less than y squared, the function is going to be defined, which means the domain is given by x less than y squared. Now, in order to sketch this domain, we're going to pretend for a second, we're going to turn this inequality into an equality. We're going to pretend that x equals y squared instead of x less than y squared. And then we're going to sketch the graph of this equation. So we can do that just by plugging in a few points. So if we set y equal to 1, on the right-hand side here, we're going to get 1 squared, so x is equal to 1. So we can say if y equals 1, x equals 1. If we say y equals 2, we're going to get 2 squared or 4, so we're going to have x equal to 4 when y is equal to 2. So if x is 4 and y is 2, then we have this point right here. What about if y is a negative number? If we say y is negative 1 quantity squared gives us a positive 1, so we're going to have y as negative 1, x as positive 1, we get this point right here. And then if we say y is negative 2, we're going to get x equals 4, so we'll have negative 2 and then 4, so we get this point here. If we plug in 0 for y, we're going to get 0 for x, and we get this point here. So what we start to see emerge is a parabola, and so we can go ahead and graph this. It's going to look something like this. So this is the graph of x equals y squared. Now, in order for x to be less than y squared, if, for example, we think about this point right here where y is 1, that means x has to be less than 1. X has to have a value less than 1. So we would want everything to the right of this particular point. That would always be the case. So, for example, up here, y is 2. We would want x to be less than that value. So to sketch the graph of the inequality, what we want to do is shade in everything to the left of this parabola. So we're going to shade in everything to the left, so that's going to be over here and over here, and then the same thing below the x-axis. Now, the only other thing we have to remember is that the inequality tells us that x is less than y squared, not less than or equal to y squared, which means that the domain of the function does not include this line itself, this graph. So what we need to do is make it a dotted line instead of, or a dashed line, instead of a solid line to indicate that this particular line is not included in the domain of the function. Now, the last thing we were asked for is to evaluate the function at the point 3, 2. So in order to do that, all we need to do is plug this point 3, 2 into the original function. So we're going to say f of 3, 2 is going to be equal to, and then we'll plug 3 in for x and 2 in for y to this right-hand side. So we'll get 3 natural log of 2 squared minus 3. And when we simplify here, we get 3 times the natural log of 4 minus 3, which is 3 times the natural log of 1. The natural log of 1 is 0, so we get 3 times 0, or just 0. So at the point 3, 2, the value of the function is 0, which means because the function can also be written as z equal to x natural log of y squared minus x, when x is 3 and y is 2, z is equal to 0. So if we were to graph this function in three-dimensional coordinate space, when x is 3 and y is 2, the value of z along the vertical axis, the value of the function there is 0. So that's another example of how to identify and sketch the domain of a multivariable function.